Okay, so what I'd like you to do while I get my camera figured out is I handed everybody a 2.3 packet. Anybody walk in, did not get one? While I was fiddling with the cameras over there. You are very welcome. Glad you guys are here. Anybody else not get one? All right, just do the warm-up problem. The graph. That is what we talked about last time. Okay. Which I want you to take that equation. I want you to solve it for y. Good morning. And I want you to find the slope in the y-intercept and graph. So the very top problem, once you're done with that, I'm going to give you 2 or 3 minutes. Once you're done, just go ahead and stop, and then we'll go through the rest, which is the new stuff together.
All right, I'm going to get started on this problem. This is review. So if you have not got caught up with what we talked about in section 2.2 as far as slope, this is what you'll see when you get to that section. So what we're going to do is we're going to take this equation, the negative 5x minus 2y is 8. In order to graph it, I would like to have the slope and the y-intercept. So that means I have to take that equation, I have to solve it for y. Okay, to put it in the slope-intercept form of the equation. So there's 2 steps. There's always 2 steps. It's always the same 2 steps. So once you've done a few of these, you've seen the steps, hopefully you'll get used to them. What's the first thing I have to do if I'm going to solve this for y? Yeah, you got to get that x term over on the other side by adding it. So I will do that. Thank you for the suggestion. And the 5x's cancel. I'm left with negative 2y. And then I have 5x plus 8 or 8 plus 5x. The order doesn't matter. I just prefer putting my variables first. Then what's the second and last thing I have to do to solve this for y? Yep, that negative 2. So divide by the whole thing. And then please just don't forget, I mentioned this last time, just don't forget to distribute that negative 2 to both terms. And so I have 5 divided by negative 2. A positive divided by a negative is negative 5 over 2x. And then 8 divided by negative 2, your calculator will tell you a positive 8 divided by a negative 2 is a negative 4. So I need the 2 bits of information. Now the first bit of information is what's the slope of this line? The slope is not negative 4. You got it reversed. Perfect, even better. The slope is negative 5 over 2. The slope is always this number that's in front of the x. If you wrote down the x as part of the slope, that is wrong. Okay, somebody in my class yesterday asked me that question. It was a very good question. The x is not part of the slope. The slope does not vary. The slope is always constant, so there should be no variable in it. Now, something I did mention last time is when you graph that negative that's with the 5 halves, you can either put the negative in the top and go in the negative y direction, or you can put the negative in the bottom and go in the negative x direction. It doesn't matter where. Just put it with one or the other and go with it. And then the second thing is, what's the y-intercept? We get what? -4. There we go. So I'm going to write that as 0, -4. There's my y-intercept. So one of the purposes of this problem is, do you understand the structure of the linear equation, the y equals mx plus b? We're actually going to begin in the next section doing problems that have us go in the reverse. So we're going to get a little more experience with this. When I go to graph now, I'm going to start at the -4. I'm going to put a dot right there on my y-intercept. And then if you chose to put the negative with the 5, that means you're going in the negative y direction and the positive x direction. So that is -5, 1, 2, 3, 4, 5, and then +2, and you make a dot. And then if I go another -5 and +2, I'm going to be down here in the next problem. You can do that, that's fine. But what I'm going to do is I'm going to, for any of you that put the negative with the bottom and had +5 and -2, so positive y, negative x, so positive y is 1, 2, 3, 4, 5, negative x is 1, 2, and you see all these line up because they're all on the same line. And if you kept counting, up 5 more and left 2 more, my line and your line will match. Even though I haven't explicitly put the dot, it is part of my graph. You can keep counting up 1, 2, 3, 4, 5, and then 1, 2, and you can see, oh, I didn't plot the point, but it's on my graph anyway. Before we move on to new stuff, questions, comments, concerns about graphing using the slope and the y-intercept. Very important. I want you to know that. I want you to be comfortable with it, because if any of you, if you're STEM students, you're going into science, you're going to see graphs, you're going to use graphs, you got to know how to manipulate them. So that's a really important skill. Anything we need to talk about further? All right, I'm going to switch cameras, and then we are going to go on to the new stuff, the section stuff. So continuing on then. What we're going to do in section 2.3, so I'm going to go down to about here. In section 2.3, what we're going to talk about is get familiar with the structure of equations of lines. We've already started this task by using the slope-intercept form, the y equals mx plus b. So this is the first equation of the line. There's going to be 3 that you have to have some familiarity with. And the first one is the slope-intercept form. Remember, math people, they are super creative in labeling things. This is called the slope-intercept form because you need the slope and you need the intercept. Okay, so y equals mx plus b. Really useful for graphing. And what we're going to do in this section 2.3, as we're learning how to use lines and learning how to use the equations, is now we're going to do the reverse process. We just did that graph that's now on your page where I gave you the equation, then you found out the information you needed so you could graph. In this section, what we're going to do, because we're learning, is we're going to reverse the process. I'm going to give you information about the line, and then we're going to, from that, construct the equation. Okay, that's our goal. So the first couple problems that are on your sheet, hopefully are going to be super relaxed and fun. So the first one, I'll do the first example. This is example 1 on the sheet. Says this. Write the equation. By the way, if you're watching this on video, this PDF is right below the video. So go ahead and print it off and just write right on it. Okay, nice and easy. Okay, so you're going to now write the equation of the line that has a slope of -3/5. So I'm just going to summarize the information right here. The slope is -3/5, and it has a y-intercept of 10. That's the information I'm given. Okay, I'm making up the problem. The whole purpose of this problem is just to make sure that we're familiar with the slope-intercept form that we started talking about last time. Okay, so we got familiar with taking it and finding the slope and y-intercept. Now, if I give you the slope and y-intercept, what's the equation? Well, here we go. It's going to be y equals what? What's the first term going to be?
Perfect. The slope goes right in front of the x. Boom. And then what's the next term going to be? Perfect. And you're done with the problem. Okay, so these first couple problems in this section are hopefully nice and relaxed. It's just building on what we talked about last time. So what I would like you to do next for me, please, is exercise 1. It's almost the identical problem, just different numbers so that you get to write stuff down. So this one gives us information. It gives us the slope is 5. The y-intercept is 8/3. My point in giving this problem is I just want you comfortable if the y-intercept is a fraction. It can be a fraction. It can be anything. Okay, so here we go. The equation is y equals, what's the first term? 5 what? X. If you wrote 5/1, that's totally fine. I don't mind that. Okay, but the 1 is implied, and since I'm not graphing, I'm not worried about the fraction. And then what's the next term going to be? Plus 8/3. Anybody struggling? Anybody have a question? Anything we need to clarify here? Yes.
Can you simplify 8/3 to 2/3?
I would. You can use mixed numbers, but in algebra, mixed numbers make things harder. So I would leave it 8/3. I'm not going to divide it into a decimal because it's going to be a repeating decimal. And so it's preferable. So if you feel like you got to give me the decimal, then I want 2.6 with the bar over it. Okay, I don't want an approximation. I want the exact representation of the answer. Okay. So yeah, if you wrote 2 2/3, I mean, I'm going to give you credit. It's not wrong, but just mixed numbers don't help anything. Okay. So great question. I appreciate asking it. All right, do the second one, please. Exercise 2, right below that. Okay, so this one, y equals, what's the first term? -1/2 x. Thank you. That's it. Perfect. Great job. -1/2 x. And the second term is -6. Okay, so that's kind of the toggling back and forth. We had the review example of what we did last time. Using the equation, we get the information. Here, I give you the information, you give the equation. Okay, so that's the slope-intercept equation. All right, so now if you're reading ahead, you notice the next problem gives us different information. Slightly. The next problem says, write the equation of the line in standard form. I'll explain that in a minute, not worried about that. We're going to write the equation of the line with a slope of 1/2, but this time instead of a y-intercept, we're given a point, 5, 7. Now you could do this problem. If you've had an algebra class and your teacher taught you how to do this problem with the y equals mx plus b, that's totally fine. I'll accept it for full credit, or credit. I guess I don't even know what a credit is. You can do that, but I'm going to show you just one thing that's going to work for every problem. Okay, that way we're doing the same thing every time. I like to do the same thing every time. So what we have in order to do this next example, the second equation of the line, there's going to be 3. First one was the slope-intercept form. The second one, this one's called, again, math people super creative. This is called the point-slope equation. The point-slope equation is this. You've got y, that's my variable y, minus y1. I'll make a note of this in just a minute. The y with the little 1, that's the y value of your point, is equal to mx minus the x1. That's going to be the x value of the point. So I'm going to label some of that while you're writing it down. So the y1, that's the y value of the point. M, that's our good buddy, the slope. We're getting used to seeing that. And then the X1, that's the X value of the point. That's the stuff we know, that's the stuff we have to plug in. So the slope-intercept form of the equation, you need the slope and you need the intercept. Boom. Point slope equation. What two things do I need in order to use this? I need a point, and then I need a slope, okay? Those are the two things. This will work for every problem. You could even do this with the previous problems, because the y-intercept would have an x value of 0 and a y value of whatever the value was. So it would totally work for that as well. But just going to use this for the rest of our problems. So the next example is just a nice plug and chug example to get us used to using the point slope form. So example 2, my example. Example 2 gives us this. We've got a slope of 1/2, and then it goes through the point 5 and 7. We've got a slope of 1/2, and it's going to go through 5, 7. So you're just going to help me plug things in the right place. Once you see where to plug things in, there's no variation. And in fact, if you can do this problem, there's no reason you can't do any of the other problems when you're given slightly different information. It's all the same problem, basically. So here goes. Here's my point slope equation. I'm going to rewrite it just so that we have it in front of us. The y without the 1, that's my variable. I'm going to keep that. So y minus, what am I subtracting on this problem? 7, that's the y value of the point. If I plug something in, you don't know where I got it from, please stop me. Let's talk about it. Ask the question you need to, because I'm going to put a problem just like this on the test you're going to have on Tuesday. Okay, if you're following along with these examples, you know exactly what's on the test on Tuesday. There's no mystery. All right, what am I going to plug in for m? 1/2. And then in parentheses, I've got x minus the x value of the 0.5. Great. Okay, that's the plug and chug. And then the rest of this is now, you're just going to put it in the format that you're asked for. Okay, and there's two formats. The first format, which is not what this problem asks. So the first format, you might be asked to put it in slope-intercept form. So you might be saying, okay, well, if I was asked to put it in slope-intercept form, Kirkster, how do I do that? And that's a really great question. There's 2 steps. The first step is you want to get rid of the parentheses. So I would distribute. Okay, so to get it in slope-intercept form, the first thing you're going to do is you're going to distribute. The last couple problems we do in this section, we will put it in slope-intercept form. So write this somewhere that you can look back at it when we get there. And then once you've distributed, the second thing you're going to do is you're going to get the y by itself. You're going to move this number. Okay, so you're going to isolate the y. So keep that somewhere safe. We can refer to it a little later. What I asked you to do, and this is the third form of the line, there's only 3, the slope-intercept form, the point slope form that we're going to use a whole bunch, and then this last one is called the standard form. You've seen a whole bunch of lines in standard form. In fact, if you look up at the example, or the warm-up problem we did at the very beginning, when we graphed -5x minus 2y equals 8, that's standard form. Standard form is when you've got your x and your y on the same side, and you've got the number on the other side. So if you follow along in the book, if you read the ebook at all, and it's fantastic, the problems, the videos, all sorts of good stuff, the standard form looks like this. It'll always be some number in front of the x plus some number in front of the y is equal to a number. And so I'm just going to write down here a little note that a, b, and c are integers. That's the standard form. So you didn't know it was called standard form, but you've seen lots and lots of equations of lines already in our first couple days, already written in standard form. So then the question, because that's what we're going to do here, is how do I get this mess right here in the standard form? Well, again, just a couple things to do. The first step is the same as if it was slope-intercept form. We're going to distribute. No, we're not. Sorry. Error. First thing we're going to do, because I don't want to mess with it, we're going to get rid of the fraction. Okay, that's better. We talked about clearing fractions our first day together, right after I gave you the syllabus. One of these equations we solved, we cleared the fraction, so it's going to be the same exact process that we'll get to review. Then, at that point, after you've cleared the fraction, then you'll distribute. And after you distribute, all that's left is you're going to put the x and the y on one side, and you're going to put the numbers on the other side. So I'm just going to summarize this last thing. Is we're going to put the x and the y on the same side. I know it seems like a lot, but once you've done it once or twice, it'll come alive for you. All right, so here's my problem. Y minus 7 is equal to a half x minus 5. If the first thing I want to do is I want to clear the fractions, what am I going to multiply all my terms by here to clear the fractions? The common denominator. What was the common denominator? 2. Yes, exactly right. So if you said 2 and I didn't hear you, I apologize, but that was the right answer. So I'm going to multiply each term by 2 to get rid of my fraction. So remember, terms are the things we're adding and subtracting together. So I'm going to multiply this y by 2. I'm going to squeeze in and multiply this 7 by 2. Now, I understand sometimes this gets a little confounding. All of this right here is one term because it's being multiplied together. So you only have to multiply by 2 on this side one time because it's all one thing. So I'm just going to squeeze it in right here. I'm going to write a 2 over 1 right in front of it by the half. You do not have to, in fact, it's wrong, multiply by 2 inside the parentheses. If you do it outside and inside, you're changing the equation because this is all one thing. It's connected together by multiplication. So that's my first step. I'm going to clear the fractions. Let's do that. So 2 times y is 2y. That's lovely. 2 times negative 7 is negative 14. Over here, what happens between these two? I got a 2 in the top, a 2 in the bottom. So they cancel, and I'm left with 1. I'm going to write it down. I know most of you realize that 1 is just 1 times anything as itself. I don't need to write it, but I just want to make sure I don't skip any steps on this problem. So when you look back later, when I'm not with you, you remember what we did. So 1 times anything is itself. So when I distribute, it's just going to be x minus 5. So that's step 2. So I cleared the fractions. I distributed the 1, and I just got what I started with. And then the very last step is I'm going to get the x's and the y's on the same side. I'm going to get all the numbers on the other side. So if I'm going to get the x's and y's on the same side, if I'm going to move this x, how do I get this x over to here? Okay, let's subtract x, right? If I'm going to get all the numbers on the right, how am I going to get this negative 14 over to there? What am I going to do? Add it. And here's what we get. And here is our answer. Here is the equation of the line that has a slope half and goes through the 0.57. And it's also written in standard form. It is this negative x plus 2y. Those are not like terms, so don't combine them. Equal stays in the middle. And negative 5 plus 14 is 9. Make one more note for you. On the test on Tuesday, if you write that, you are 100% correct. That is standard form. That is perfect. I love it. Move on to the next problem. But some students last semester told me that in my math lab, for some reason, I don't know why. I actually need to send them an email and ask them. My math lab wants the x to be positive for some reason, and I don't understand it. So here's a simple thing. If you finish your problem and the x term is negative, so this is for my math lab only. This is not for my test. Okay, that is 100% correct. For my math lab, all you're then going to do is you're just going to change the sign of everything. So instead of a negative x, you'll have a positive x. Instead of a positive 2y, you'll have a negative 2y. Instead of a positive 9, you'll have a negative 9. Those are equivalent equations. One is not better or worse than the other. Okay, so again, I don't understand, but my math lab likes the x positive. So just make sure you do that. I don't want you to get the problem wrong there and they get frustrated and when you've done the thing right to begin with. Okay. So bunch of stuff there. starting with the point slope form. So the next problem on your sheet, it's exercise 3. It's the very bottom of this first page. Does the same thing. Gives you a slope of 3/4 through the point -1, 3. So write the equation of the line in standard form. That does that. All right, let's check this out. I have another one that we're going to do just because we're practicing the point slope form. This is the plug and chug. So here we go. I'm not going to rewrite this. You're just going to help me plug stuff into the right place. So it starts off y minus what? The y value, which is 3, fantastic, is equal to the slope, excellent, times x minus, you're subtracting a -1. Okay, so don't forget that this minus is part of the point slope form. That negative comes with the 1. That was the number given. So when I subtract a negative, what does it become? Okay, plus. Okay, that's the important step. Getting it in the right place. That is 75% of the battle right there. Yes.
Why you got X plus 1?
Okay, because this is a -1 right here. When I subtract, okay, I'm subtracting my x minus whatever the value is. So in this case, I've got x minus a -1. And when you subtract a negative, 2 negatives make a positive. Okay, that's where the plus comes from. Okay, good to be clear on that. Excellent. Anybody else got a question? Love questions. They're good. All right, so now 75% done. Now I got to get rid of the fraction. What am I going to multiply every term by? 4. It's the only denominator, so it's the common denominator. So I'm going to multiply a 4 by my first term, a 4 by my second term. Remember, this is all the third term, so I'm going to multiply by a 4 there as well. So we have 4 times y is 4y. 4 times -3 is -12. Here, the 4's cancel. That's what I want. And so I've got to, and if you can do this all in one step, I'm totally cool with that, but I'm writing it all out for everybody. A 3 times the x plus 1. You still with me? Did I lose anybody on that step? Distribute. The rest of this is stuff we've been doing since the first day. Okay, that's the hardest part right here, getting to this form, I think. That's my opinion. You might differ from me in that. So 4y minus 12, I'm going to distribute. I've got 3x and then plus 3. Now I'm going to put the x's and y's on the same side and the numbers on the other. So I get this 3x over here by doing what? That's indeed true. I'm subtracting. And then I'm going to get this 12 over to there by adding. And then here is the final answer. And since we're not in my math lab, we're going to be done. So I've got a -3x. Great. I've got a plus 4y. Fantastic. The 12s cancel, my equals always stays in the middle, and then 3 and 12 is 15. That is the equation of the line that has a slope of 3/4 and goes through this point right here. Anything we need to clear up before I give you one more? One more exactly like this so that you're just running through the steps and getting comfortable with them, because that's the big chore here. All right, flip the page. Top of the page, exercise 4. Again, same sort of thing. And then after that, we're just going to see 2 other variations, but it's going to be the same thing we're doing now. All right, I'm going to begin. If you're still working, keep working. No rush. So I start off, it's y, then what? Okay, why is it plus? Because we're subtracting a -6. When you subtract the negative, it becomes +6. My slope is -2/5. It's fifths, right? Not thirds. Yes, I wrote it down right. And then x minus 3. Wonderful. Okay. Challenge number 1 is getting all the information in the right place. Challenge number 2 is clearing the fractions. What am I multiplying all my terms by to clear the fractions? 5. Indeed, that is true. So 5 and 5. Then I'm going to squeeze a 5 in right there. So now I will do the clearing the fraction step. 5 times y is 5y. 5 times 6 is 30. Here the 5's cancel, and I'm left with a -2 out in front of my x minus 3. Yes? Yeah, that's totally fine. If you wanted to multiply by a -5, if any of you did that, then your terms look like this. So you got a -5y here, you got a -30 here, and a +2 in front of this. So your signs are going to be different. It's equivalent equation though. So I think when you get to the end, you'll have the exact opposite signs of me. That's cool. Okay, don't, it's not wrong. It's not better. It's not worse. It's the same. All right, excellent. Great question.
How come it's not a -5 times like distributed?
A -5?
Yeah.
Because I multiplied by a 5 in order to get rid of this denominator. So it cancels. It's now gone. There's no more 5 left to distribute anywhere. Okay. All right, so let's finish this out. The rest of this hopefully looks sort of familiar if you've been keeping up with your homework. So I'm now going to add the 2x over here to get it on the left with my y, and then I'm going to subtract the 30 to get it over on the right with the other numbers. And so we should all have this or the exact opposite of this written down. So we have 2x plus 5y, and then on the other side, 6 minus 30 is negative 24. I add, because my goal is to get the negative 2x over to this side. So we always do the reverse. So instead of a negative 2x, I add 2x, because now those will cancel. It's no longer on the right, it's now on the left as a positive 2x. The 30, I subtract the 30 because this is a plus 30. We do the reverse. The reverse of adding 30 is subtracting 30 from both sides. All right, so here is the next problem. I'm going to do this one with you, but it is essentially the same problem. So this is example 3 on the sheet. This time, though, instead of being given a slope and a point or a slope and the y-intercept, this time I'm given 2 points. I want to know, and this is really good, if any of you take statistics, you're going to do predictions. You're going to do predictions with lines. You're going to take data. You're going to figure out, and then you're going to draw a line that kind of splits the data. And the way you do that is you get a couple points that are predicted, and then you make the equation using this process right here. So we're going to get our line that goes through negative 4, 3, and also goes through 5, negative 7. This is a great problem because it gives us an opportunity to review something that we've already talked about before our test comes at us. So I want to write the equation of the line. Again, we're asked to do it in standard form. So right when you see that, write the equation of the line. I know that I'm going to use my point slope form. Here's my question. Do I have a point to plug in? I got 2 actually, I got a choice. Do I have a slope to plug in? No. But do I have the information available to me to figure out the slope? Yes. So that's the only thing on this problem that's different than the previous one. You're not given the slope, but you're given the information. So we get to review. So I'm going to come over here. I've got to find the slope. My slope is the ratio of what over what? Rise over run, y's over x's. Okay, so what's my difference between my y's? What do you want to do in the numerator? What are we going to subtract? What do you want y2 to be? Okay, negative 7 minus 3. Fantastic. So remember, okay, I made a big production of this the last time. It does not matter which point is 2, which point is 1. All that matters is you are consistent. So since I heard first to do negative 7 minus 3, so we went from here to here, what do I now have to do? I am locked in to what in the bottom? 5 minus negative 4. 5 minus negative 4. And when you subtract the negative, it's going to be a plus 4 at the bottom. So my slope becomes negative 7 minus 3. That's negative 10 at the top. 5 plus 4 is 9 in the bottom. And now I have the information that we were given in the last problem. You with me? It's the same problem. You had to use something previous to figure this part out. All right, so here we go. Y minus. Now again, both of these points are on the line. It does not matter which one you pick. Okay, I have no secrets. Remember, I will always tell you if there's a secret. Okay, so I'm just going to pick this one because it's closer. I don't have to reach. I'm going to use negative 4, 3. If you use 5, negative 7, you will get the same exact equation of the line that I get. Okay, there will be no difference. All right, so negative 4, 3. So my y value is 3. My slope is negative 10 over 9. X minus the x value is negative 4, so that's x plus 4. At this point, it's the exact same problem we've done. So I want to repeat this. I'll get both those questions. I want to repeat this. Mr. Perkins, could I have used 5, negative 7 and have y plus 7 here and then x minus 5 here? Yes, it will be the same thing. It's not better. It's not worse. The only wrong thing you can do is to pick the y here and then the x here. If you use the different points, that's bad. Your hand was first. I answered it. Your hand was second. Because you don't need both. These need to stay the variables, so I'm not going to plug anything in there. I want oh, I erased it. I want an X and a Y in my final equation. So you don't plug in both, you just pick your favorite. Okay, and this one, for whatever reason, there's no secret reason, this was my favorite. All right, so I'm just gonna kind of scroll through the rest of this because we've seen it 3 times. It's the same process. I'm gonna multiply everything by 9 to clear the fraction. 9 times y is 9y. 9 times -3 is -27. When I clear the fractions, the 9's cancel. I have -10, x plus 4. Remember, once you get used to the steps, it's the same steps every single time. Okay, that's the good news about this. I'm going to distribute -10x, -40. And then the rest of this is just rearranging the problem. I'm going to lift it up here because I know this table obstructs the view for some of you. So I'm going to add the 10 to both sides, the 10x, excuse me. So I get on the left side, I get 10x plus 9y. I'm going to add the 27. Remember, we're doing the opposite to both sides to move these terms around. And then the -40 plus the 27 is -13. And there we go. Your next problem is just like that one. You're going to find the slope. You're going to pop it in. You're going to go ahead and clear the fractions and finish it up. So this will also be the last one we put in standard form. So if you have a standard form question, please ask it. I would like you to do exercise 5. Might be up to you. I'm going to get started on the busy work here. So again, if you're still working, that's fine. I'm not telling you that you're too slow or anything. I'm just cutting the middle here from some people already done, some people still working. So here we go. I need a point and I need a slope. Again, I'm given 2 points. So I have an extra one, but I need them both to find the slope. So my slope, we all should get the same slope, even if you did the work in a different order than I did. I'm going to do -4 minus 5. That's my difference between the y's. And so then my x is 1 minus -2, or in other words, 1 plus 2. So the top -4 minus 5 is -9. The bottom 1 plus 2 is 3. Oh, that's lovely. No fraction this time. That makes my work even a little nicer. -9 over 3 is -3. Great. I've got my slope. I've got my point. Again, it doesn't matter what one you pick. I'm just going to use this one because I'm lazy and it's closer to me. Okay, if you use the other one, it's totally fine. So we've got y minus 5 is equal to -3, x plus 2, because I'm subtracting a -2. No fraction to clear, great, I saved myself a step on this problem. -3 times x, -3 times 2, and then the last bit is just moving stuff into its appropriate place. X's and Y's on one side, numbers on the other, and we will be good to go. So I'll add 3x. I get 3x plus y on the left. On the right, when I add the 5, -6 plus 5 is a -1. And I'm done. All right, we've got one more style of problem. It's the same problem again. Okay, so I'm going to have one, and then you're going to have one, and we'll be done with this section. And then the last section of this unit is shorter than the rest. Yes.
So that equation, I start with -9 and 3, and then I multiply terms of 3. So this is not like.
So what you have is 3 times what I have. Right, you have a 9y, you have a 9x, a 3y, and a -3. And that happened because you didn't reduce. It's the same equation. You have what's called a dependent equation on this. All multiples, so if I can multiply all the terms by 5, by 9, by -6, all multiples of this are called dependent equations. Okay, so it's not wrong, it's the same, but in general, you know, when you reduce it, make the numbers nicer, it's a little cleaner. Okay. Yeah. That's a great question. The My Math app will want the most reduced one. Okay, on my test, I won't care, but if you notice that something can be reduced it, My Math app will mark it wrong. Great questions. All right, here's the last style of problem. It presents us with the same issue we just saw. So this is example 4 on the sheet. Example 4 says, okay, we're going to write the equation of the line. This time we're using slope-intercept form, so that's great. We'll get to practice the top over here. It's going through 6, -3, and then this time we're given slightly different information. We are told that it's going to be parallel to this line, 2x plus 3y equals 6. Well, again, this is nice. It allows us to review some stuff we talked about last time. Does anyone remember from last time? What's true about lines that are parallel? What's true about their slopes? They're the same. Okay, so once again, I've got my point slope equation right here. If you need to write this down, write it. If you don't need to write it down, that's totally fine. I'm doing that for your benefit. I need a point and a slope. I've been given a point, and once again, just like the last problem, I've not been given the slope, but I've been given enough information to find the slope. So what I have to do is I have to find the slope of this line. Well, we already did that today, right? We did that. That was the review problem. To graph that equation, we found the slope. What do I have to do to this equation to find the slope? Do what? I have to subtract 2x because I have to solve for y. Yes, you're indeed right. Okay, so I'm going to subtract the 2x. So I'm finding the slope here. I'm just going to write a little note, a little asterisk to myself here. I'm finding the slope. That's what I have to do. And then I can go ahead and plug it in and I'll be ready to rumble. So I'm going to subtract the 2x like I was told to do. Remember, this is always the same 2 exact steps every time, never any different. Now I'm going to divide everything by 3. We did this at the top of the hour when we graphed. So I have -2 over 3, that's -2/3 x, and then 6 over 3 is +2. So what's the slope of that line? So what's the slope of my line? Yes, great. I'm going to call a timeout on this problem. Look at the next one, exercise 6. We're not going to do that one all the way through. There's only one word different in exercise 6. Anybody identify what the one word that's different in exercise 6 is? It says perpendicular. Circle the word perpendicular, okay, for your notes. That's the one thing that's different there. Who can remember for me what we said last time? This is again reviewed. If the slope of this line is -2/3, what's the slope of my line that's going to be perpendicular? What are you going to use there? Okay, everybody blended together. It was a nice chorus. I appreciate that. I'm hoping this is what you said. Remember, you change the sign, so we're going to make it positive. And then what do we do with the fraction? Flip it. So I'm hoping all of you were saying, mumbled together, +3/2. So if you want to finish that later, that's fine. So write in exercise 6 that the slope you would use, m equals +3/2. Okay, that's the only difference in that problem. But just for time's sake, we're not gonna do both. I'm gonna have you do the very last one. So I'm gonna use the -2/3. I'm gonna pop it in here, and then we're gonna be just about done. So here we go. Y minus the y value. The y value is -3. So y minus a -3 is y plus 3. My slope is -2/3. X minus the x value is 6. I did not ask for standard form on this problem. The last two we do, I asked for the slope-intercept. So here's what you do. Just look back in your notes or read right here. We're going to distribute, get rid of the parentheses, and then we're going to get the y by itself. All right. -2/3 times x, that's the easy part. That's -2/3 x. A negative times a negative is going to be positive, but I know when we see fractions, sometimes we freak out. Your pulse gets quicker, your stomach gets queasy. So I'm just going to come over here in my scrap work. I've got to multiply 2/3 times 6. I'm going to write the 6 as 6/1. Does anyone remember how to multiply fractions? What do we do? Well, it depends what you mean by cross. That's why I don't teach students to cross multiply when they solve proportions. If you mean by cross, you go tops and bottoms. Okay, you go, no. So great. I'm glad we're having this discussion. When you multiply fractions, you do not do the x thing. Okay, that is when you solve what's called a proportion. We will actually do that in this class in the 4th unit. Okay, so we'll get our chance. The way you multiply fractions, it's tops and bottoms. You're just going to go straight across the top, straight across the bottom. Okay, it's a little easier. Yes. How come I didn't multiply what by the 3? Oh, because I'm not putting it in standard form. I don't need to clear the fraction. Slope-intercept form is solved for y, so I want to keep the y by itself. So the way we're going to do that is we're going to distribute, and then our last step is we're going to bring this 3 over to there. Okay, so we don't have to clear the fraction for slope-intercept form. Great question. So here we go. 2 times 6 is equal to 12. 3 times 1 is 3, and then my calculator will tell me that 12 divided by 3 is 4. And then the promised last step is I'm going to get the y by itself because that's what slope-intercept form is. It's solved for y. So I subtract 3, and I get y is equal to -2/3 x plus 1. And then we can graph it if we wanted to. Well, we could have graphed it at the beginning because we had enough. Question? I'm really sorry, I cannot hear you. It's -2/3 times the -6. That was right there. So a negative times a negative is going to give me +4. I just didn't deal with the signs over here because I'd already done that. Sorry about that. I didn't go lose you on that detail. All right, last problem for this section, exercise 7. It's the same sort of thing. You're going through a point, you're parallel to the line. Write it in slope-intercept form. No, what's that? Right, we start with all these columns, we started with the point slope equation because we can get that information plug in, and then in this one, we're going to put it in the slope-intercept form. Yes. Great question. At the end of this problem, I'll summarize real quick the 3 different kinds of lines we have, and then we'll be done with this section. I'm gonna get started. If you're still working, keep working, okay? So there's nothing wrong with you if you're still working. I don't want you to feel stressed about it. So I've been given a point, that's what we need, point. Then I need a slope, okay, to plug in here. So the information I've been given is, once again, my line's gonna be parallel. That's the clue about the slope that I need. How do I solve this for y? This was only 1 step. Subtract the 3x, put the x over on the other side. So I get y is equal to negative 3x plus 5. So what's the slope of that line right there? Since I'm parallel, what's the slope of my line? Negative 3, yes. No trick question, just making sure we're all tracking along. So now I've got y minus a negative 1. So y minus a negative is y plus 1. My slope is negative 3, x minus 9. I did ask for slope-intercept form, not standard form. So I'm going to distribute and get the y by itself, and we're done. So distribute, negative 3 times x, negative 3 times negative 9, no fractions this time, that's lovely. And then I'll subtract 1 from both sides. And again, it's the same steps every time. I know it's a lot to process at the beginning. That's why I practice it, sort it out. It's the same thing every time. So to summarize, we have 3 equations of lines that we're using. Slope-intercept form we introduced last time, we graphed with it. The point slope form is the key to unlocking all of these problems. That's what we start with. And then sometimes we give our answers in standard form, which is sometimes we're given problems to graph in standard form. And that's section 2.3.